Let's simplify this rational expression by first factoring apart the numerator and the denominator. So in the numerator, I think we can break this up into two pieces. Probably the same thing is true for the denominator. So for the numerator, we have to have an x and an x, and I want two numbers that multiply to a negative 15. The negative means one has to be positive and one has to be negative. If I do positive 3 and negative 5, the sum of those two numbers is negative 2, and the product is negative 15. I'm going to use the same idea in the denominator. Okay, I want an x and an x. I want two numbers that multiply to a positive and add to a negative. That means they both have to be negative. And, okay, if it's negative 1 and negative 5, the product of those two is positive 5, and the sum of those two is negative 6. So we've factored the expression. So now comes the part where, okay, I want to cancel any common factors. And I see I can cancel the x minus 5s. I cannot cancel the x plus 3 with the x minus 1, and that means that's all that is left over. X plus 3 divided by x minus 1. And you don't have to include the parentheses because there's only one factor in both the numerator and the denominator, so I'll write my answer like this. The thing to point out is you can't just start canceling like the x squareds with the x squareds, and the reason is you can only cancel factors, which is why we break these apart. Let's try that same idea in part B. Now, this looks a little bit more complicated than what is up here, but I think that means we'll just have to remove a greatest common factor. So if I look at the numerator, I need a greatest common factor. It looks like I can remove a 2 and also an x. So when I start this process, I'm going to factor 2x from two terms in the numerator. And I'm left with x plus 7. So I think I can do something similar in the denominator. There is a greatest common factor. It looks like I can take out 4 and x. So if I remove that, 4x, left over we have x squared. Okay, I have plus 4x, and I'm going to have a minus something, and I'm removing 4. You could check this in your calculator if you want to. I believe it's going to be 21. But if we divide out 4, we get 21. So we're not quite done yet because I still have to factor this piece. So I'm going to continue. I'm going to copy down my factored numerator. But now I want to factor the last part of the denominator. Okay. I need an x and an x. I have to have a positive and a negative. I want two numbers that multiply to negative 21, yet add to positive 4. And I believe those two numbers are going to be 7 and 3. And here we have some common things. I can cancel a factor of x plus 7. Oh, I see there's numbers as well, like 2 goes into itself once and into 4 2 times. But also, we have an x to the first power and another x to the first power. Those things are exactly the same. I'll bring in a different color here, but I can cancel that x with that x. And my job is now to just write down what is left over. In the numerator, I have x plus 7. There's also a 1, but I'm not going to write that. In the denominator, I have 2, and also x minus 3. And I think this is an acceptable way to write the answer. Again, you could, if you wanted, write x plus 7 in the numerator. I think it's customary to leave the answers factored, so I'll leave it as 2 times x minus 3 in the denominator, but this is my final answer. Moving on to multiplying rational expressions, the idea is the same. I just want to factor and cancel any common factors. Looking at this first one here, with my first fraction, there is nothing that I can do. Maybe I'll just put some parentheses around them just to indicate that we're talking about factors. I'm multiplying this by, okay, in this second fraction, we can clearly factor. I'll start with the numerator. Again, I want an x and an x. I want two numbers that multiply to negative 12, yet add to negative 1. and those two numbers would have to be -4 and +3. In the denominator, again, I want an x and an x. Okay, I need a positive and a negative. I need two numbers that multiply to -4, yet add to -3. So that would have to be -4 and +1. So at this point, it's now just a matter of canceling all of the common factors. Like I see there's this x plus 1 and this x plus 1, but also we have this x minus 4 and this x minus 4. What is left over is an x plus 3 and an x minus 5, and again, I'll just write this as x plus 3 over x minus 5, and that is my final answer. All right, for the next part here, this is a little bit more complicated just because I now have to factor both fractions. Like perhaps the first fraction breaks into two pieces in the numerator and the denominator, and then the same thing is true, hopefully, for the other fraction, like this. I'll start here. Okay, I have to have an x and an x, a positive and a negative, two numbers that multiply to 28 and add to 3 are going to be a +7 and a -4. The product is -28, and they sum to 3. In the denominator of this fraction, I need two numbers that multiply to -8, yet add to -2. Okay, so that's going to be, I'll have an x and an x, a positive and a negative. I think it's going to be -4 and +2. The product is -8 and the sum is -2. Great. With this numerator here, okay, x and x, I need definitely a positive and a negative. It's going to be +2 and -1, and the reason is the product is -2, and they sum to a +1, which isn't written here, but it is implied. Now for the denominator, okay, everything is positive, so I can just put plus signs over here. Two numbers that multiply to 35, yet add to 12. Okay, this one's a little bit easier, I think, but it's 7 and 5. The product is 35 and the sum is 12. All right, a little bit more work here, but everything is completely factored, and now I can cancel. I see this x plus 7 cancels with that x plus 7. This x plus 2 I see cancels with that x plus 2. Oh, and also this x minus 4 cancels with that x minus 4. All that is left over is x minus 1 and x plus 5. And that, again, I'll write like this. And that is my final answer. Okay, continuing with the same idea here. These all look a little bit different than the previous problems, but I think that's because we're going to have to deal with greatest common factors here. I'll try to fit that in, but here, the greatest common factor of this numerator is an x. I see I can take out x from both terms, but I can't take out a number, so I can remove an x from this. In this denominator, the greatest common factor is 1. Nothing can be removed. Over here, there's another greatest common factor. I'll write that below. The greatest common factor appears to be, okay, this time it's x squared, but you can't remove a number. And in the numerator, the greatest common factor is 1, so I can't factor anything out there. Let's start with this numerator. I'm going to take out an x. That's the greatest common factor. And what is left over is an x and a 3. The denominator is simply x plus 5. Nothing can be removed. I'll focus on the denominator next. Okay, I'm going to remove x squared from both terms. That's the greatest common factor. And I have x plus 3 left over. Okay, that's great. But what about the numerator? I think we can factor this into two pieces. I'm going to try. We have an x and an x. There's no x's in the middle. We're saying there are 0 x's. There's only a number at the end. Since the number is negative, it has to be that it's an x plus and an x minus. I want two numbers that multiply to negative 25, but add to 0. It's just not written in the equation. And so the answer is it's 5 and negative 5. Product is negative 25 and the sum is 0. So here everything is factored. I can cancel the x plus 3's. I can cancel an x plus 5. And also, there's an x to the first, and then there's this x squared here. This means I can completely cancel this, and I can reduce this by 1. So I removed one x from the denominator. This makes my answer, I have x minus 5 in the numerator, and only x in the denominator. So this is my final answer. Okay, same idea in the denominator here, in the next problem. Let's see. All right, there's no greatest common factor that can be removed here, nor is there a greatest common factor here, but I'm noticing in this fraction there is definitely greatest common factors. In the numerator, it's simply 4, and in the denominator, it's 8, just numbers. Okay. Well, I think the numerator probably can be factored into two pieces, and hopefully the same is true for the denominator. But if I now focus on the second fraction, the numerator has a greatest common factor of 4, and if I remove it, I get x minus 2. The denominator has a greatest common factor of 8, and if I remove it, I get x plus 5, okay? Well, I've done what I can there. All right, if I focus on the denominator, this actually looks a lot like what was happening up here. You know, there's x squared, the number, but nothing is in the middle. And that just meant these were equal and opposite. I'm going to apply that idea here. I know for the denominator, it's got to be an x and an x. It has to be a positive and a negative. The answer must be 2 and negative 2. The product is negative 4, yet the sum is 0. But what about the numerator? I'm going to try to solve that separately. I'm kind of not sure how to factor it. So I'm going to do some work off to the side. What I'm going to do is take the product of these two numbers, which is 4, and I'm going to look at factors that sum to 5, which are actually just 1 and 4. And I'm going to use this approach of, okay, I'll take the 5x and write it as x plus 4x. I'll then remove the greatest common factor from the first two and the last two terms. And then remove this common factor from both terms. And that leaves me with 2x plus 1. And then there's an x and a 2 left over. So I use this approach because it's hard to guess the factors if the number in front of here is a 2 instead of a 1. So this is how it factors. I'm going to place those things here. All right, that is 2x plus 1 and then x plus 2. And now we can do the fun part, which is canceling all of the common factors. Like this x plus 2 cancels with that one. This x minus 2 cancels with that. Oh, and 4 goes into 8 twice. If I copy down everything that is left over, in the numerator there is 2x plus 1. In the denominator there is a 2, but also an x plus 5. And again, in the numerator, I'll just put 2x plus 1 with no parentheses, but I will leave the denominator factored, and that is my final answer. Okay, when it comes to this part where we're dividing instead of multiplying, all it means is we're going to rewrite the problem. This division is going to become multiplication. So I'm just going to copy down the first fraction. The first fraction is x squared minus x minus 2, x squared minus x minus 12, but we're going to flip the second fraction, which is x squared plus 2x minus 3, and then x minus 2. The reason is, when you're dividing two fractions, you multiply by the reciprocal of the second fraction. And once we've changed the problem, now it's just a matter of factoring it. So let's start with the first fraction. I think we can break this apart into two pieces. For the numerator, it's got to be an x and an x, a positive and a negative. It's going to be positive 1 and negative 2. And the reason is the product of those two things is negative 2, and the sum of these two is negative 1. I think we can do something similar for the denominator. We get an x and an x. It's got to be a positive and a negative. And two numbers that multiply to negative 12 yet add to negative 1 are going to be positive 3 and negative 4. The product is negative 12. The sum is negative 1. I'm done with this fraction. I'm now going to factor this one. So the nice thing is the denominator is factored. Great. But the numerator is not. I have to have an x and an x, still a positive and a negative, and two numbers that multiply to negative 3 yet add to 2 would be positive 3 and negative 1. Everything is completely factored. And I see I can cancel an x plus 3, an x minus 2, and that's it. Left over we have x plus 1 and x minus 1 in the numerator, and in the denominator we have x minus 4. Now I'm just going to leave it like this, even with the parentheses in the denominator. Okay, let's use that same idea in this second problem here. All right, I'm just going to use this process where I'm going to copy down the first fraction, change it to multiplication, and flip the second fraction. Because now, what I can do is go back to this factoring approach. I see that there is a greatest common factor here. I'll make note of that. The greatest common factor is x. And also, there's a greatest common factor here. It's also x. Making note of these two things, let's factor. In the numerator of the first fraction, I can take out an x, and x plus 5 is left over. In the denominator, I think we're going to have to break this into two pieces. You have to have an x and an x. Everything is positive. Two numbers that multiply to 1 and add to 2 are actually both 1. 1 times 1 is 1, and 1 plus 1 is 2. I've completely factored this fraction. Okay, now what about this? I'll start with the numerator. If I factor the numerator, I have an x and an x, and I want two numbers that multiply to 6 and add to 7, and okay, I don't think the choice is too bad here. It's got to be 1 and 6. The product is 6, and the sum is 7. All right, let's look at the denominator. Again, we decided that the greatest common factor is an x, so I'll write that down. And what is left over is x plus 1. I can now cancel all common factors. I see there's a bunch of x plus 1s, and it doesn't matter which one we choose. I'm going to say, let's cancel this with that. I see that there is not much else. There is this x and that x, but that is all. Left over in the numerator, I have x plus 5 times x plus 6, and in the denominator, I have x plus 1 and x plus 1. So those things actually did not cancel, so they are left over, and this is my answer. To add or even subtract two fractions, you need a common denominator. So before we actually solve this problem, I just want to look at something somewhat similar. Like if I said, I want to add a half and a third. The two denominators each have one factor, and clearly the least common denominator is going to be the product of those two things, which is 6. So you have to know that first. So to proceed, you actually have to change both fractions, so this is the new denominator. Here's how that works. You would take a half, and you're going to multiply in what is missing, which is the 3. Now for the second fraction, the 1/3, you're going to multiply, in what is missing, which is the 2. So I take my two fractions that I started with. I saw I wanted this to be a 6, so I multiplied by a 3, and I just did the same thing to the numerator. Over here, I saw that the denominator was 3. I knew I had to multiply by 2, so I did that to both the numerator and the denominator. At this point, I know I have a least common denominator of 6. And my numerator is going to be 1 times 3, which is simply 3, plus, then we're going to have 1 times 2, which I'll write here, and that's simply 2. So, no surprise, the answer is 5/6. I wanted to work this out because over here, the process is going to be identical. Step 1 is going to be, well, what's my least common denominator? These two denominators have one factor each, and they're both different, so I'm just going to multiply the two together, which is going to be, I'll take x plus 5 and multiply that to x minus 1. That's my least common denominator. So now I go to my fractions, and I have to multiply in what is missing. On this first fraction, I wanted an x minus 1. It's not there, so I'm going to multiply by x minus 1. But I have to make sure I do the same thing in the numerator. So this step, it looks very different, but it's the same idea as this step here. Here I had a 2, I was missing a 3, so I multiplied it in. Over here, I was missing an x minus 1, so I just had to multiply it in. If I continue to my second fraction, I have to ask myself, well, what's missing? What's missing is the x plus 5, so you have to multiply that in. And once you've done this, you have a least common denominator. And I'm going to write it as x plus 5 times x minus 1. It's the product of those two things. Now my numerator is going to be 1 times x minus 1. I'll put that here. That's simply x minus 1. And then over here, I have 2 times x plus 5, which I'll write like this. So the step that I just did here is identical to this step. I wrote down my least common denominator, I multiplied these pieces together, and added them, and that was it. Now if I want to simplify this, I'm going to leave the denominator alone, but I will distribute in the 2 and combine like terms in the numerator to take this one step further. So I have x minus 1. If I distribute the 2, I get 2x plus 10. This is all divided by x plus 5 times x minus 1. And if I combine like terms, I get 3x plus 9 all over x plus 5 times x minus 1. And that is it. That's the answer to this problem. All right, so let's try this again, but in the second problem here for part B. Again, the goal is I need to find a least common denominator. And the issue is this time that, well, okay, this first fraction's okay, it's just x minus 1. But over here, I can factor this a little bit. I'm going to remove the greatest common factor. So just looking at the denominator, if I take out an x, I'm left with an x minus 1. So really, this denominator is this. I'm trying to find the least common denominator between this and this. And I see that my least common denominator must be x times x minus 1. The reason is, if I multiply this denominator by x, it'll be exactly the same as this denominator over here. So let's see what that looks like. For my first fraction, I'll write it as 3 divided by x times x minus 1. And I'm claiming that for my second fraction, I can simply multiply in what is missing to end up with the least common denominator. And the thing that is missing is the x. So now I can express this as x times x minus 1, my least common denominator. My numerator is going to be 3 plus, and over here, 2 times x, which is 2x. And I'm going to leave the denominator alone I can't combine like terms in the numerator, so that actually means that this is my final answer.